Hello, I'm Janet. In today's class, we'll learn how to solve logarithmic questions without tables. And they can come in different forms. Like this one, we have 3-in-1 question that we'll try to answer or solve. So let's solve this. The first one is solve the equation. This is still logarithm. If 1, it says 3 to the power of 2 raised to the power of x minus 30 to the open bracket 3 to the power of x plus 81 is equal to 0. So whenever you're given a question like this, you say let 3 raised to the power of x be equal to, let me call it y. Okay, so I'll replace this with y. So what we have is y squared minus 30y plus 81. It has become a quadratic equation, so we'll multiply the constant with the highest with the variable with the highest power of y, which is y squared. We multiply 81 by the constant by y squared, so it becomes 81y squared. So we'll look for the sum and product. I like to look for it this way by looking for the prime factors of 81. The prime factor of 81, we use the least common prime factor of 81 is 3. 3 in 8, that's 2, remaining 2. 3 here is 7. 3 can divide 27, that's 9. 3 and 3, 3, 1. So if we say 9 times 9, that will give us 81. But when we say the product, 9 plus 9, that will give us 18. But we're looking for 30. So let's combine 3 times 3 times 3, that gives us 27. So when we say 27 times 3, that gives us 81. When we say 27 plus 3, that will give us 30. So we have gotten the sum and product. But this is minus 30. So minus 27 minus 3, that will give us minus 30. Minus 27 times minus 3, that's minus times minus plus 81. So this is the factor. So we have y squared minus 3y minus 27y plus 81 equals 0. You group them in bracket. So what's you factorize? Y is y minus 3. 27 is common here. We have y minus 3 equals 0. So we'll pick one of these. They are the same. Y minus 3, this and this, y minus 27 equal to 0. So we'll find the value of y, the two values of y. Y is equal to 3 because y minus 3 equal to 0. Y minus 3 equal to 0 is y equal to 0 plus 3. So that means y is equal to 3. We have gotten the first value of y. Then the next value is y minus 27 equal to 0. Y equal to 0 plus 27. Then y equal to 27. But so what we have is, remember we said 3 raised to the power of x is equal to y. The same thing here, so we solve. If 3 raised to the power of x is equal to y and y is 3, so we have 3 raised to the power of x is equal to 3. 3 raised to the power of 1 is still 3, so x is equal to 1. We have gotten the value for x, and then the first value of x, and then the next one is 3 raised to the power of x is equal to 27, because y is 27 here. So 3 raised to the power of x is equal to 3 raised to the power of 3. 3 raised to the power of 3 is 27. then x is equal to 3. The next question, given that log 5 base 3 is equal to 1.465, evaluate without using tables, meaning we are not using the table to solve this. This is what we are evaluating, this question. Okay, said log, that's the B part, log 25 base 3 plus log 15 base 3. So this becomes log base 3 5 raised to the power of 2 plus log base 3. There's no number that we can raise 15, or any number that we can raise to the power, or that can multiply itself and give you 15. So but then we have 3 times 5 will give us, okay, will give us 15. So here we have 2 log 5 base 3 plus log 3 in logarithm, when you are multiplying the numbers, it means you are adding, plus log 3 5. So recall that log 5 base 3 is 1 point, so I'll replace this one, is now 2 times log 5 base 3 is 1.465 plus log of the same log 3 base 3 is 1 plus log 5 base 3 is still 1.465. Okay, so multiply 2 by this, it gives us 2 times 5, that's 10. 2 times 6, 12, plus 1, 13. 2 times 4, 8 plus 1, 9. Then 2 times 1 is 2.2 plus 1 plus 1.465. Adding up everything, this is 3 figures. 1 plus 1 is 2. So we have 2.930 plus 2.465. 0 plus 5 is 5. 6 plus 3 is 9. 9 plus 4 is 13. Move 1. 2 plus, then put your decimal point. 2 plus 2 is 4 plus the 1 is 5. So that gives us the value without using table. The next one still is without using table. It says evaluate log base 10 5 plus log x plus 2 base 10 minus log x minus 1 base 10 is equal to 2. So the whole of this becomes log base 10 5 plus log base 10 x plus 2 minus log base 10 x minus 1. Remember, the log of a number is the number of times the base is raised to the power. So we have log 10 raised to the power of 2. Okay, that's how we got this 2. Now let's rule the log out. So we have 5. When it is plus, you are multiplying. 5 times x plus 2 minus is divide x minus 1 equals 10 raised to the power of 2 is 100. That's 10 times 10, that's 100. So let's make it over 1. Opening the bracket, we have 5x, 5 times 2 plus 10 over x minus 1 is equal to 100 over 1. You cross multiply. Cross multiply. So we have 5x plus 10 is equal to 100 times x is 100x, minus 1 times 100 is 100. So we collect like terms. Collecting like terms, we have 5x, 100 moves over here, becomes minus 100x is equal to minus 100, then plus 10 moving over here becomes minus 10. So this is minus 95x is equal to minus 100 minus 10 is minus 110. So we divide both sides by the coefficient of x, which is minus 95. So minus 95x over minus 95 is equal to minus 110 over minus 95. So x is equal to, minus to cancel minus, 5 can divide this. 5 in 11 is 2, remaining 1. Then 5 in 10 is 2. 5 in 9 is 1, remaining 4. And 5 in 45 is 9. So our answer is x is equal to 22 over 19.